Okay, so Assalamualaikum warahmatullahi wabarakatuh and good evening everyone. Saja hari ni tukar tempat sikit. Asyik tempat yang sama je, bosan. So kita tukar-tukar sikit. So jauhnya benda ni. Sekejap nak adjust bagi dia. Tu dah jatuh habis semua barang. Whoops. Okay, better I think. Okay, so semua orang dah key in lah, attendant. Key in dah. Okay, so let us start then, so that we can finish lecture 3 quite fast, and then we can start with chapter 8. So I think I'm gonna finish chapter 7. I think if you give me half an hour, I think I should be able to finish this lecture, and then we're gonna spend around another hour for chapter 8. Okay, so now let's start. Oh, by the way, kalau tiba-tiba gelap ke apa ke, mohon maaf lah. Line dia memang tak stable. Setiap kali buat live je tak stable. Ampere. Oh, hi everyone. Hi Fatha. Hi Hafizah. Hi Aisyah. Hi Fatihanis. Next. Okay, so at the end of the lesson, so for today, you should be able to find the combination of a set of object with condition and then determine the number of ways to form combination of art object from n different object. Key in dekat mana, Miss? Oh, ingatkan kena key in dekat borang kehadiran pelajar online BKPO. Bukan dia ada yang khas untuk maths. Tak ada Kalau tak ada tak apalah, ignore je lah. Okay, next. Right, so combination of a set of object with condition. Alright, so what is the definition of condition? Oh my god, I didn't say hi. Macam mana boleh tiba-tiba je dia tulis hi kat situ? Saya tak tulis pun. Oh, scary. Okay, definition of combination. A combination is a selection of n distinct object with no consideration given to the order of the object. So we only select the object. We don't really consider whether do we select the object first or second as long as we have the object. Okay, so that is a difference between permutation and combination. In a permutation, the order of the object is important, whereas in a combination, the order is not important. Okay, so in a permutation, the order of the object is important, whereas in a combination, the order is not important. Okay, so for example, from 3 pictures A, B and C, the permutation of 2 objects are AB, AC, BC, BA, CA and CB. Okay, so for this permutation, AB is not equal to BA. So what does it mean? AB, A on the left hand side, B on the right hand side. BA, that means B on the left hand side, A on the right hand side. So we got two different things. BC also not equal to CB because one of them B on the left hand side, another one B on the right hand side. And CA also not equal to AC because one of them on the left hand side, one of them on the right hand side. Therefore, the total number of permutation is 6. So in permutation, the order is important. So AB is not equal to BA. So AB is the first way to arrange them. So AB, second is BA, third is BC, the fourth is CB, the fifth is CA, the sixth is AC. However, in combination, the order is not important. Therefore, AB is simply equal to BA because we can have both the A and B. BC also equal to CB because we will have both B and C together. AC is equal to CA because we are going to have A and C together. Okay, next. Therefore, the total number of combination is only 3. Determine whether each of the following is a permutation or combination. Okay, so for example, 5 pictures placed in a row. So for example, we have 1 picture, 2 picture, 3 picture, 4 picture, 5th picture. And then we want to arrange them in a row. Picture 1, picture 2, picture 3, picture 4, picture 5. So is this a permutation or is this a combination? So we must ask ourselves, is the order is important or the order is not important? If the order is important, it's supposed to be a permutation. If the order is not important, it will be a combination. So if you want to arrange them in a row, it will be very ordered. That means we are supposed to know which picture will come first, which picture will come second, which one will come third, and so on. Therefore, this is actually a permutation. So we are going to put some order for them. Okay, next. 3 storybooks pick from a rack. So daripada rak buku, we're gonna pick 3 of them. Okay, so for this one, we simply gonna pick them. That means it doesn't really matter which book that we pick first, as long as we have altogether 3 books. Therefore, this is the case of combination. Okay, next. A team of 9 players chosen from a group of 20. So let's say we have 20 candidates and then I only want to have 9 players in my team. So out of 20, I only gonna choose 9. So since it means chosen, that means it doesn't really matter who I choose first as long as that person is in that group. So this is the case of combination. So tak kisahlah siapa yang kita pilih dulu. Sometimes we might choose goalkeeper first or sometimes we might choose goalkeeper as the last person. As long as we have the goalkeeper in that group, that is okay. So that is what they mean over here. The arrangement of the letters in the word October. So since you want to arrange the letters in this word, that means if let's say I wrote down BER and REB, those are two different things sebab this is the letters or huruf. Letters, the arrangement for the letters, it can mean two different things, whether we have BER or REB. Therefore, this is actually the case for permutation. Okay, next. Types of food in a plate taken for lunch consists of rice, vegetable, and chicken curry. Okay, so basically you're gonna choose either rice and veg or chicken curry and rice and so on. Okay, so it doesn't really matter which one you take first, right? As long as at the end you will have all 2 of them or all 3 of them. Asalkan kita ada je kan. So this is the case for combination. Okay, so now, therefore, we can conclude that permutation are used when the order is important and combination are used when the order is not important. So if you want to pay more attention on the order, then that is permutation. If you don't really care, as long as you have them, that is the case of combination. Okay, next. The combination of R object from n different object. The number of combination of n different object taken R at a time is NCR, where NCR is equal to n factorial over R factorial times with n minus R factorial. So this is the formula NCR. So out of n, I only want to choose R. So this is basically the formula. So please remember them because most of the time if we need to prove something, then we might need to use the definition of NCR, which is n factorial over R factorial and minus R factorial. Okay, so let us go to the second example. There are 6 bottles of liquid dye consisting of the colors red, green, blue, yellow, white and black. Calculate the number of selection of the mixture of 2 different colors from the available 6 colors. Okay, so out of 6, I want a mixture of 2. So that means out of 6, I want to choose any 2. So it will become 6C2. So we want to choose two different color from the 6 colors. So 6C2 is also equal to 15. Okay, next. In a test, a candidate is required to answer 8 out of 10 questions. Find the number of ways a candidate can answer the questions. Can answer the question if the first 3 questions must be answered. Okay, so we have 10 questions, and it say over here that candidate can answer the question. Okay, so this is 8 out of 10. So it will be 10C 8. So out of 10 questions, we're going to choose 8 of them to answer. So 10C8 is actually equal to 45. Okay, so B. B it said that the first 3 questions must be answered. So we have 10 questions altogether. So I can separate them into 3 and another 7. Why is that? Because the first 3 questions need to be answered. Okay, so out of these 3, all 3 of them must be chosen. So it will become 3C3. So now, we said we want to answer only 8 questions. So I already choose 3 questions from here. So that means I will be left with another 5. So that 5 is chosen from the 7. So it will be 7C5. So that means now we already answered 8 questions. So 3C3, that is because we have a special condition where we must choose the first 3 questions. So 3C3. 7 is the other questions other than the first 3 questions. So we have left another 7 questions. So out of that 7, you need to choose another 5 so that we will answer 8 questions. So 3C3 times with 7C5. So this is 21. Okay, next. If there are 8 girls, okay, so we have 8 girls and 7 boys in a class, in how many ways could a group be chosen so that there are 2 boys and 2 girls in the group? So I want to have 2 boys and 2 girls in the group. Okay, so out of 8 girls, I only want 2 of them, so it will be 8C2. Out of 7 boys, I only need 2 boys, so 7C2. So the number of different ways is 8C2 multiplied with 7C2. So altogether, we are going to have 588. So 8C2 times with 7C2. Okay, next. Hopefully you guys are doing well. Okay, next. Okay, so A, B, C, D, E, F, G, H is a regular octagon. How many triangles can be formed with the vertices of the octagon as vertices? How many diagonal can be drawn by joining the vertices? Okay, so let us draw the octagon first. Okay, so this is the octagon. Okay, so what is the number of triangle? Okay, so basically we need to ask ourselves, in order to draw a triangle, how many vertices do we need? Okay, triangle. So 1, 2, 3. So altogether, I will need 1, 2, 3 vertices. Okay, so a triangle has 3 vertices. So now 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 vertices. So out of 8, I only gonna choose 3. So out of 8, I will choose 3 vertices. So it will become the number of triangle. So from 8, daripada 8 ni kita pilih mana-mana 3 vertices dan kita akan gabungkan dia untuk dapatkan triangle. So out of 8 vertices, we only gonna choose 3 vertices to make a triangle. Okay, so the number of triangle will become 56. The next one, the number of diagonal. What is a diagonal? A diagonal is the line segment linking two non-adjacent vertices. So two non-adjacent, that means it cannot be side by side. Okay, so now I want to link two vertices. So out of 8, I will choose 2. 8C2. However, if I simply do 8C2, the answer might be A until B, because we simply do 8C2. So I might get something like A to B. But I don't want them because I want the diagonal. That means it should either A to G, A to F, A to E, A to D, and so on. Okay, so I don't want AB or even AH. So what should I do is that I should minus 8. Why 8? Because we have 8 sides. So 1, 2, 3, 4, 5, 6, 7, 8. So since I have 8 sides, if I minus them, I will get all the diagonal. So it will become 20. Okay, so that is the end of the combination. Okay, so done with this, let me proceed with chapter 8. Okay, so rest sekejap. Meanwhile, saya kena set up sekejap. Saya pelik lah. Kenapa orang tu dia suka buat macam tu lah? Kenapa dia kena masuk saya punya? Kenapa dia kena copy? Tak faham betul. Rasanya korang kan macam kena ignore kawasan yang sembang-sembang tu. Ada makhluk tu. Tak faham betul. Okay, so probability. What are my chances? Okay, so in probability, we are talking about the chances. What is the chances that it's gonna rain tonight? Or what is the chances that you're gonna get an A? Or what is the chances that you're gonna score 4.0? So those are chances. So in probability, we are talking about chances. Okay, next. So this is the first lecture. So firstly, you should be able to define the concept of experiment. What is an experiment? And then what is the outcome, the event, the sample space, and then the random selection. And then you should be able to state the basic law of probability and then find the probability of an event. And then later on, we're going to see how to draw the tree diagram and how to read from the Venn diagram and how to read from a contingency table as well. Okay, so probability. Probability is the chance of an event occur. So for example, if let's say I give you 4 pen, the green pen, the red pen, the black pen, as well as the blue pen, what is the probability of choosing a black pen? Or what is the chances that you're going to choose a black pen? Okay, so now, what is the answer? The answer for this is 1 out of 4. The chances is 1 out of 4 because we only have one black pen and altogether we have 4 pens. So it will be 1 out of 4. So the chances will be 1 over 4 or a quarter. So some definition that we need to know. What is an experiment? Experiment is an action that lead to one of several possible outcome. Outcome is the observation or the result from the experiment. So for example, if let's say the experiment is to record the grade of an examination. So your examination or your UPS test before this, what is the outcome of the grade for them? Okay, so it should either be A, B, C, D, E, or F. So those are the outcome. Tossing a coin. So we toss a coin, toss yang baling tu, toss a coin. So when you toss a coin, it should either be a head or tail. Rolling a die. So satu dadu, die. If we have two, ada dua dadu, we gonna call them dice, D-I-C-E. So rolling a die, what is the outcome that you are going to get? So it should either be number 1, number 2, number 3, number 4, number 5, number 6. Okay, next. Sample space. Okay, so sample space is a list of all possible outcome of an experiment. It can be illustrated by using the Venn diagram, the tree diagram, or the set notation. And what is an event? An event is a collection of outcome or a subset of the sample space. Example 1. 2 coins are tossed. So those are the 2 coins. So we have the head and the tail. Okay, so this is our sample space. So we might get a head for the first coin and then another head for the second coin, or a head for the first coin, a tail for the second coin, a tail for the first coin, a head for the second coin, or both tail for the first and the second coin. So those are our sample space. So that is the list of all possible outcome that we might get when we toss 2 coins. And the number of the number of all possible outcome in our sample space is equal to 4 because we have either HH, HT, TH, and TT. So altogether we have 4 possible outcomes. If let's say Y is an event, so Y is now an event, let Y be an event of getting at least 1 head. So what is the possible outcome for them? Getting at least 1 head. So the possible outcome for Y is either 2 head or HH, or the head for the first coin, tail for the second coin, or tail for the first coin, head for the second coin. So we're gonna have HH, HT, TH. So this is the event of getting at least 1 head. So if I ask you, what is the number of all possible outcome for this event? That is actually equal to 3. So sample space, event, the number of outcome in the event. Okay, so now definition of probability. Probability is a measurement of whether a particular event will or will not occur in any random experiment. A probability is a number between 0 until 1. So it shouldn't be more than 1 and it shouldn't be less than 0. So tak boleh ada probability yang negative and we cannot have a very big number for the probability. Or you can look at this timeline or those interval. Okay, so if let's say the probability is equal to 0, you calculate them, P of A is equal to 0, that means event A is impossible to happen. So contohnya lah kan, what is the chances of getting a snow in Malaysia? So the chances is 0. Yang tapi kita bukanlah masuk bangunan-bangunan tau. Bukanlah masuk bangunan yang ada salji. The real snow I mean, not artificial snow. Getting a real snow in Malaysia. So the chances are 0, which is totally impossible. And then one certainly happen. What is the chances that Malaysia will have sun? Macam kelakar je. Sekejap. What are the chances that KMK will rain in 1 month? Within a month lah. Within a month, it will rain. So that is totally possible. And certainly possible. Sebab biasanya kita jarang kan panas kan dekat sini kan. Biasanya dalam sebulan tu mesti hujan. So what are the chances? The chances is one, definitely 100% possible. Okay, so if let's say we have a chances of 0.5, it simply means that they are around 50-50. It might happen, it might not happen. So the chances are around 50-50. Might happen, might not happen. Okay, so always make sure probability is always in between 0 until 1. So 0 is impossible, 1 that means that event will certainly happen. In general, the probability of an event A occur is denoted by PA. So this is the probability of event A occur, PA, where PA is the number of possible outcome in that event A divided by the total number of outcome, which is in our sample space, or normally denoted by NA over NS. So N, that means we want to know the possible outcome for that event. What is the number for the possible outcome for that event? And then divide with the total number of all possible outcome or our sample space. So those are NS. Okay, next. You have to take note of a few things. PS is equal to 1. The possibility of any outcome to happen in our sample space is equal to 1. Maksudnya semua benda tu lah, kalau kita tambah semua benda dalam sample space, the probability should be equal to 1. And the probability of A happen should be in between 0 and 1, including 0 and including 1 of course. Kalau dia impossible to happen, 0. If it is certainly to happen, it will be equal to 1. So dia boleh sama dengan jugalah. Okay, next. Example 2. A ball is taken from a bag containing 3 red. So we have 3 red ball and 2 blue balls. What is the probability of getting a red ball? Okay, so let us draw a bag. So that is a bag. We need to have 3 red balls. So altogether we have the first red ball, second red ball, the third red ball. So those are the red ball. And we have 2 blue balls. Blue, blue. What is the probability of getting a red ball? Okay, so what is the total number of red ball? So that is 3. The total number of blue ball, that is 2. The total number of balls altogether is 5, because we have 5 balls altogether. So what is the chances of getting a red ball or picking a red ball? So that is the number of red ball divided with the number of sample, which is 3 over 5, or the chances is 0.6. Kejam gila. Letak dislike banyak-banyak. Siapalah makhluk ni. Penat aku buat live. Dia boleh buat dislike oh. Kejam gila. Entahlah. Okay, so now probability of getting a red ball is 0.6. Next. Find the probability of obtaining a number greater than 4 on a single toss of a die. Okay, so we need to know when we toss a die, what is the outcome that we are going to get. So list down all possible outcome. So when tossing a die, we can either get number 1, number 2, 3, 4, 5 or 6. And then we want a number that is greater than 4. Okay, so the total number of sample space is 6 because we have 1, 2, 3, 4, 5, 6. So NS is equal to 6. And then the event is obtain a number that is greater than 4. So this is our event. Obtain a number greater than 4. So what is the possible outcome for them? Greater than 4, it should either be a 5 or a 6. So NA will be equal to 2. So those are the possible outcome for event A. So P, probability of getting a number greater than 4. So NA over NS, or 2 over 6. So this is 1/3. You must give your answer in the simplest form. Okay, next. Right, so Venn diagram, tree diagram, and contingency table. Sometimes relationship between events can get complicated. So tools like Venn diagram, tree diagram, or contingency table may be used to visualize the problem of probability. Okay, so Venn diagram show relationship between different group of outcome of one event, including the union, intersection, and complement event clearly. Contingency table, it will show the observed frequency for two variables in various category. Tree diagram, each branch assign the probability of an event. This is used to solve conditional probabilities. And the way we find the probability is that we have to multiply the probability along the branch and then we're going to add them vertically. So I do think it will be better if we can see the example first before you can say that you didn't understand this thing. Yang ini saja nak tunjuk je lah probability, we can actually describe them in these three forms. So you boleh guna Venn diagram, boleh guna contingency table, boleh guna tree diagram untuk kita keluarkan semua data tu. Sekejap Okay, next. Right, so this is the Venn diagram. Okay, so we have A, event A, event B, and then we have A of lab with B right in the middle. So in the middle here, this is A of lab B. That means A happened and B must happen at the same time. Okay, and then A until B over here, this is A union B. So that means either A or B. So everything here from here until here, those are A union B. Okay, so in example 4, in a certain group of 100 students, so we have a total of 100 students. That means in your sample space, we have 100. So this is an S number in our sample space, 100. Okay, so 54 studied calculus, 69 studied physics, and 35 studied both. Okay, of course, we need to have a Venn diagram first. So we need to have physics, calculus, and then both. So since I have only 2 events, so that is the reason why I'm using some Venn diagram. So this is perhaps physics F lah. Side P nanti kita pening F, and then calculus, let us use a C. Okay, so 35 studied both. So for me, I prefer to put the both first sebab dia overlap kan. So kawasan overlap kita letak dulu. So this is 35. So 35 studied both. 54 studied calculus. So altogether inside the calculus is 54. So 54 you minus with 35. So that is the answer for the number of students who studied only calculus. So the answer is 19. And then 69 studied physics. So we have 35 students who studied both. So that means the student who only study physics is 34. Okay, so now what did the question say? If one of these students is selected at random, find the probability that, okay, so firstly, I need to make sure, do I have any student that didn't take either physics or calculus? So the student that didn't take any of it is 100 minus 34 minus 35 minus 19. So I have 12 students that didn't take neither physics or calculus. Okay, so sekarang dah ada 100 students, so we can start. Okay, so find the probability that the student took calculus or physics. Okay, so what is the probability? Okay, so yang ini yang lukisan cantik sikit lah. So boleh salin nombor ni dulu. Okay, so once you have drawn this one, let us calculate then. Okay, so probability. Taking calculus or physics, so it will be 34. So this is C union F. So it will be 34 plus with 35 plus with 19. And then divide with the total number of students, which is 100. So 34 plus 35 plus 19 divide with 100. So this is equal to, oh mana jawapan dia? Kena kira lah sekejap So this is 88 over 100. Or you can say that this is equal to 22 over 25. Okay, the next one. Probability that the student take neither, dia tinggal T lah kat situ. So probability that the student take neither physics nor calculus. So the student didn't take physics and that student didn't take calculus as well. So that means this one, the one that is outside of the physics and calculus, which is 12. So we got a 12 divide with 100. So this is 3 over 25. Okay, now a C. Probability of that student taking physics but not calculus. So only physics, not calculus. So you only need to refer to this one. Only physics, not calculus. So this one is not used because 35 student did take calculus. So kita tak nak, kita nak hanya physics. So that student cannot take calculus at the same time. Therefore, it's supposed to be 34 over 100. So 34 over 100. So this is equal to 17 over 50. Okay, next. Okay, so now example 5. A coin is tossed twice. Find the probability of getting at least one head. Okay, so this is normally what did I do. I'm using some tree diagram for them because after the first event, I have another event. So this is the first toss. So this is the second toss. Okay, so for the first one, the chances for me getting a head is 0.5. The chances for me getting a tail is also 0.5. So the chances are 50-50. So 0.5 unless the coin is a biased coin. So kalau coin tu bias or unfair coin or biased coin, then they should let us know what is the chances of getting a head and what is the chances of getting a tail. So the question should at least tell us what is the chances of getting a head and a tail. So you should read the question very, very carefully. If they say that the coin is a biased coin or the coin is an unfair coin, then you should read further to find out what is the chances of getting a head and what is the chances of getting a tail. But you need to make sure that both chances, when you add them, it should be equal to 1 because the probability of sample space is equal to 1. Okay, so now for the second one, again, we will get either a head or a tail. So head, head, tail, tail, head, head. So head, 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 tail, tail, head, and tail, tail. Okay, so now we want to know what is the probability of getting at least one head. Okay, at least one head. So that means we can either get two head, 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 tail, or tail, head. So what is the probability? Okay, so to find the probability, we need to multiply along the branch. So in order to get a head, probability of head, so this one is simply equal to 0.5 multiply with 0.5. So 0.5 square. So that is how we get head times head. How to get probability of head times tail. Head and tail, of course. So probability of head times with probability of tail. So again, this is 0.5 square. And then another one, probability of tail head. So probability of getting a tail first and then a head. So multiply along the branch. So 0.5 times 0.5. So this is 0.5 square. Okay, so multiply along the branch and make sure you add all the possible probability together. So the answer for this one is simply 0.75. Okay, next. A survey is conducted on a group of workers comprising production operators, administrative officers, and security guard. The survey is to determine the total working hours in a week. So we have production operator, administrative officer, security guard, and then we have, this is for the hours. So either less than 40 hours in a week or 50 to 70 hours in a week, or perhaps more than 70 hours in a week. As you can see, we have two very different things. So satu bercakap tentang the workers itself, either production operator, administrative officer, or security guard. And then kita ada the number of hours less than 40, 50 to 70, greater than 70. So kalau kata kita nampak terlalu banyak info dekat dalam data kita, biasanya kita akan guna contingency table. So this is quite useful when you have a lot of things to consider. Okay, so one of the worker in the survey is randomly selected based on the information provided. Calculate the probability. Okay, the first one, the worker being a production operator. Okay, so the first thing that you need to do is calculate what is the total number of worker. So you can either add them from here to here, or you can add them from here to here. So add everything, do make sure you have what is the total number of worker. Okay, so now the worker being a production operator, so this is a production operator. The total number for the production operator is 196. So that means the chances of choosing the worker that is a production operator is 196 over 270. So you can actually simplify them and it will be equal to 98 over 135. Okay, next. The workers who work between 50 to 70 hours. Okay, so now 50 to 70 hours. So that means if we look at the total number of the worker is 70. Altogether in our sample space is 270. So the chances is 70 over 270. And this is equal to 7 over 27. So we simply read our table, go to the most right hand side, and then see what is the total number of worker that satisfy that thing. Okay, next. The worker being an administrative officer and working greater than 70 hours. Okay, so now I give you some time for you to try. Read the question and then try to give your answer. Tulis answer lah. At least dapatlah jumlah yang menarik sikit. So, what is your answer? Cuba tulis jawapan awak apa? 4 over 135. Okay, so now let us check. Okay, so the worker need to be administrative officer and working greater than 70. So administrative officer is over here. Since we have N, that means it should satisfy this one as well. Working more than 70. So they meet at 8. So we have 8 over 270. So it will be 4 over 135. So okay lah, pandai lah baca table. Okay, next. The worker being a security guard working less than 40 hours. Okay, so yang ini pula. Cuba try. Dapat berapa? Security guard working less than 40 hours. Four over 270. And your answer is correct. Betul lah. Security guard. So security guard. So this is 4. Less than 40 hours. Also 4. Okay, so it does satisfy both of them. So 4 over 270. Or this is 2 over 135. Betul? Farah dengan Aisyah. You guys dua orang je ke yang ada kat dalam ni? Mana orang lain? Cuba bagi shout out sikit. Cuba tulis nama sikit. Hai ke apa ke? Asal yang lain macam senyap je. Sebab ada orang tu tadi Mana orang lain ni? Hilang dah ke? Ada je. Dah lah, dia rasa macam sedih sekejap. Nampak 20 watching je. Takut nak buka komen. Saya pun takut juga. Menakutkan betul. Sabar je lah kan. Awak China. Biasalah. Nanti tiba-tiba kan saya kata apa tahu. Oh, takut nak buat live. Saya hantar video je lah. Sabar je lah. Okay. Siapa lagi yang ada ni? Ada je. Tak lah, bagilah saya confidence sikit. Sedih lah tengok orang macam tu tau. Tulis komen. Sedih gila. Faham betul saya. Kalau tak nak tengok, tak payah nak tengok. Kenapa nak masuk kalau tak nak belajar? Okay, next. Okay, so complementary event. Okay, so what is complementary event? So you might perhaps have heard of A complement or A prime. Ada setengah tu dia macam AC. Kadang-kadang kita tulis macam tu lah, A complement. Okay, so the complement of event A is called not A. Is the event that event A does not occur. So sometimes we can write them down as A prime or A bar, or you can even write down as AC. So this is A complement. Okay, now, right. So if A is this event, so yang bulat ni adalah event A, then A complement or A prime or A bar or AC is outside of the A. So this is A complement. That means not A. So the rule is that the chances or the probability of A complement is actually 1 minus probability of A. Probability of A is actually 1 minus probability of A complement, and then probability of A complement, if you add together with probability of A, then this is actually our sample space. So altogether the chances is actually equal to 1. So probability of A complement plus with probability of A should be equal to 1. Okay, next. Right, so now let us learn how to read the Venn diagram. Okay, so we have event A, event B. So basically, if kawasan ni yang kita lorek, if this is the shaded region, it simply means that A happened. Okay, so A complement, A does not happen. So other than A, everything else you shade. So that means A complement or A does not happen. And again, we can either use A bar or we can use A, C. Next. Right, so A overlap with B. So that is this one, right in the middle. So that is the shaded region. What is A overlap with B means? It means that A and B happen simultaneously, or we can say that both event A and B happen. So they must happen at the same time. So both A and B happen. So that is for A overlap B. Alright, so A overlap B prime. So that means A happen, however, B does not happen. So that is the reason why we have B complement over there. So A must happen and at the same time B cannot happen. So A happen but B does not happen, or we're gonna say only A happen. So we cannot have B happen at the same time. Okay, so this one, what is this? This is A union B. A happen or B happens or both happen. So we can either have A happen, B happen, or both A and B happen. So A union B, so everything, at least one of them happen. Okay, next. A complement overlap with B complement. So that means both A and B do not happen. That means neither A nor B happen. So both of them cannot happen at the same time. Both of them cannot happen. Tak boleh A, tak boleh B. Okay, next. Right, so A overlap with B prime. So that is this one over here. A overlap with B prime. Union with A prime overlap with B. Only one happen. So either A or B happen. So they cannot happen at the same time. So it can either be even A happen without B happen, or even B happen without A happen. So they cannot happen at the same time. So that is what they mean over here. Okay, so this one. A overlap B prime, A prime overlap B, and then this one right in the middle, both of them happen. So this is A overlap with B. So from the event A until event B, that is actually A union B. Okay, so the thing that is outside of them is A union B prime, or the complement of A union B. So A union B, dia ada complement dekat situ lah. Ataupun nak letak prime pun boleh juga. So A union B prime. Ataupun bar macam yang dibuat kat sini lah. Or you can also write them down as A prime overlap B prime. So yang ni sebenarnya guna De Morgan punya rule. So probability of A union B prime. So this is actually probability of A prime overlap with B prime. So yang ni sebenarnya De Morgan lah. De Morgan rule. Okay, so now I think this is the last example, I guess. Example 7. Given the Venn diagram below, find what is the probability of B happen, probability of B prime, so that means other than B, we should add everything together. And then A prime overlap with B, so that means we should only look at what do we have inside the B without A overlap with B. And then this is only A happen and only B happened. We want to see what is the value. Okay, next. Probability of B. Okay, so what do we have here? Okay, so this is 12. Both A and B happen. That is 8. B, this is 7. Outside, that is 73. So that means firstly, we need to know what is the number of sample. Okay, so 12 plus 8 plus 7 plus with 73. Okay, so tambah semua dulu lah. 12 plus 8 plus 7 plus 73. So your sample space is equal to 100. So NS is equal to 100. So that is our sample space. So we want to know what is the chances of B happen. Okay, so we're gonna add everything inside the B. So semua sekali kita akan tambah. So it should be 8 plus with 7. So 8 plus 7 over 100, or you can simplify them to become 3 over 20. So this is the chances of B happen. Okay, so this is PB. So always make sure you add first to find out what is the number of sample. Okay, next. Probability of B prime. So that means outside of B. Other than B, what is the number? Okay, so this is B. Outside of B, so we have a 12 and we have 73. So it should become 12 plus 73 over the number of sample, which is 100. So we got 85 over 100, or this is 17 over 20. Okay, so this is probability of B prime. Or actually, we already have PB earlier, right? So if you don't want to use the Venn diagram, you can say that PB prime or B complement, this is actually 1 minus probability of B. So you can do 1 minus 3 over 20 and you will get the same answer over here, which is 17 over 20. So benda yang sama sajalah. Cuma since the question asks us to use the Venn diagram, so kita cuba tengoklah kalau berdasarkan Venn diagram dapat nilai berapa. Okay, so that is B. So let us proceed to C. C, probability of B happen, but A cannot happen. So only B happen. So we cannot have A of lab B. So sebab itu yang kawasan ni tak boleh lorek lah. So only B. Okay, so the number is 7. So it's supposed to be 7 over the total number in our sample space, which is 100. So 7 over 100. So cannot simplify further kan sebab 7 tu prime numbers. So we're gonna leave them as 7 over 100. Okay, so probability of A prime of lab with B, that is 7 over 100. Okay, next, D. Probability of A happen but B cannot happen, union with probability of B happen but A cannot happen. So kita hanya ambil bahagian yang dalam tu sajalah without A overlap with B. Okay, so we're gonna take the 12. So this is for probability of A overlap with B prime. And then this is probability of A prime overlap with B. That means B happen, A cannot happen. So we got a 12 plus with 7 and then we're going to divide them by 100. So 12 plus 7 over 100, or the answer is 19 over 100. Okay, let's see. Do we have any other question after this? Oh no, so that is the last one. Okay, so that is the last one for the first lecture of probability. So I say thank you very much for listening. Okay, so sorry lah ada manusia yang macam tu pula, tak apalah. Kalau kata student yang mengaji dekat college, bawa lah taubat. So boleh tak cakap situ? Okay, right. So for everyone, thank you for listening. Thank you for hearing. And I'll see you guys whenever I see you. Thank you very much. So jumpa besok untuk kuliah. Bye-bye.